Hi, my name is Bevan, and this video will be a little bit about myself and the project that I'll be presenting for the 2024 UAlbany Showcase. So a little bit about myself. My name is Bevan Babu, and I am a junior at UAlbany. I major in biology with a double minor in both computer science and informatics. I really like creating things, and the informatics course that I'm taking, CINF 196, gave me the tools and the skills necessary to start making whatever I wanted to. So my future plans are to go into med school, but I want to always keep my passion towards creating and continue to add skills to my arsenal. So what did I create for the 2024 UAlbany Showcase? I created a Macropad, which has 10 buttons per layout, and it has a possibility for up to 16 layouts in total. It also has a rotary, which you can see right over here, a rotary encoder that has a fixed function, which is a volume function, so increase, decrease volume, and it can also pause and play music or videos. So what did I use to create this Macropad? To create this Macropad, I actually followed a step-by-step tutorial, and I'll post the link to that website in the description. But a quick rundown of the supplies and tools that I needed were 11 key switches and key caps. The key caps I 3D printed, the key switches I bought from Amazon, a custom built case which I also got from the website, one Arduino Pro Micro, one Rotary Encoder, 11 IN4148 Diodes, 4 LEDs, one 330 ohm resistor, some 24 gauge silicone electrical wire, one micro USB to USB cable, a 3D printer and 3D printer filament, soldering equipment, wire strippers, or an X-Acto knife. So some of this material was left in the Makerspace where I created this, so I just used it from there. So most of the materials you would need to buy in bulk, so if you mess up, you can always replace the piece and try again. Or if you don't need replacement parts, you can always create more than one and give it to family, friends, or even sell them. So now that you have all the materials, we're going to get onto the steps. So step one is going to be 3D printing and inserting key switches. So you would get the STL file from the website and you would print it. It is around 4-hour print in total. And then after that, you'll want to insert your key switches as shown here. To insert the key switches, you'll have to insert it into the front of the top part of the case, as seen in this photo. So next, you're going to start soldering. So soldering is the most time-consuming part, and it's also the part which is easiest to mess up, so you have to be really careful. So here's a schematic for what should be soldered and where it should be soldered. This is all changeable. If you do change it and you don't follow this, you would just have to change it in the coding step. So the schematic that was provided in the tutorial didn't have the same labeling as the actual Pro Micro that I got. So after some research, I found this translation image. You can basically just use this to know where to solder the wires into the Pro Micro. So for example, if you need to solder into, let's see, not 7, we'll try up here at 16, not 16, at 20. We'll try over 20. So if you, this last row would have to be soldered into 20. There is no 20 on the actual Pro Micro, but if you look over here, there is a translation to 20 in Arduino, which is the language that we're going to be using to code. So you would put the wire for this, instead of in 20, you would put it into A2. So the first thing that you should be soldering are the diodes. So to set up the diodes, you would get them as a straight diode like this on the left, and then you would want to make sure that the red part is at the top and the black part is at the bottom, and bend the wire. You want to bend the part that's at the red and then loop it around and then add that into the key switch, which you would then solder right over here. So after you do this, you should get something that looks like this right here on the left. After that, you would have to connect the columns and rows, and to connect the columns, you would need to get copper wire and then strip the parts that connect to the metal beam on the key switch that wasn't used on the diode. So these parts right over here, you would have to strip, and then you would connect it onto the key switches. After that, you would have to connect the rows. You could also use wire for this, but I personally just connected the diodes to each other and just left it like that. After you solder the columns and the rows, you would then want to connect the LEDs and the rotary knob in the same way. So once everything on the board is soldered, you would want to connect everything back to the Pro Micro using the schematic that was shown before. So one quick tip that I want to give you is to not be stingy with the wire, the amount of wire that you use. That was the one mistake that I made. In this way, I'm not able to bend the Pro Micro anywhere, so I had to create another case to hold the Pro Micro. If you use more wire, you would be able to bend it back and forth, and it would be easier to fit into the case that was given in the website. And always remember when you're soldering to wear your safety glasses. So the next step after this is a coding. So this is somewhat easy if you do have coding experience in Java or C++. Majority of the code was given in, so all of this code, it was given in the website. I did make some modifications to the Rotary Encoder and what each key does. So the first part of the code is importing other files that were already created, and then you would be declaring which part of each key was connected to what. So this is basically where you're telling the Arduino IDE where each item is connected, to on the Pro Micro. So if you didn't solder it in the way that the schematic showed above, you would have to change these values to where it was soldered, to where you soldered it. So the setup code is so that's the main code over here, the declaration code. Then you have the setup code. So the setup code is what is being played at the start of when you plug in the Macropad or when it turns on. This would basically be any animation. There is a starting animation which I made over here. It basically just turns on the LEDs and then turns them off. And then after that code is the layouts. So this is where you would customize each layout to what you want it to be. My first layout is a regular numpad. So 1, 2, 3, 4, 5, all the way to 9. And that's my first layout. After that, you can switch layouts to my second layout, which has some cool features like screen recording or opening up Explorer, and there are other vacancies which I would code later on. And then the third layout is just all the number 1. Any key you press would just print out the number 1. And then after that is layout 4, which is the alphabet, or the first 9 letters of the alphabet, which is also something that I need to change at some point. So finally is the loop code. The loop code is the part that is actually being played by the Pro Micro, and this is how the Pro Micro knows which layout is being used and what the keys mean. So it runs through the code, and each, depending on the layout, it chooses a different key for the key that you press. So that was all the coding, and then over here is the encoder. There is the media next, so if you press it, it goes to the next media. It pauses, plays and pauses, and you can also control the volume with it, which is this part over here. So after all of these steps are followed, you would get your final product. All you need to do is assemble it, and you should get something like this. I use some screws here. I didn't fully put it in, but you should be able to completely screw it in. And yeah, that's the final product that the Macropad that I created for the Fall 2024 showcase. Thank you so much for watching the video, and I hope you learned something or were inspired to make your own Macropad. The rest of this video is just going to be myself soldering in a time skip, as well as a time skip of the 3D prints that I did. Hope you enjoy. You can control the volume, you can play, and you can pause, and each key has its own meaning. And this is used to change modes.